My presentation today concerns everyone in this room. I study blood transfusion. 1 in 3 Australians will get transfused in their life, so if not you, someone of your loved one will. So after donation in one of the blood service collection centers and before transfusion in a hospital, blood is first split into its 3 main components, which are red blood cell, plasma, and platelets. And each of these components is stored in a way to maximize its shelf life. Red blood cells, which are today's topic, are stored in an artificial storage solution called SAGM for up to 42 days at 4 degrees. During these periods, the cells will age as they would naturally in your body, but in a bag, there's none of the cleaning mechanisms that will take care of removing the old dying cells or removing the cell's waste. So as a consequence, it is reported that aging will be accelerated in storage. This is actually a problem because the red blood cells, they need to deform very strongly to flow through a very narrow section of the circulatory systems. And echinocytes actually transform shape when they age. They go from being this smooth cell called discocytes, that you can see on the left side of the picture, and afterwards they become round and acquire spikes all over the surface and become echinocytes. And echinocytes, because of the lower surface area to volume ratio, can't deform as well as discocytes, and they get blocked by the liver, which acts as a filter for all the red blood cells. So transfusion of a bag, which has a high echinocyte content, are thought to have a reduced transfusion efficiency. So this shape transformation from discocyte to echinocyte is not well understood at this day. So my project is to propose a mechanism for it. So I collaborate with biologists, engineers, and physicists to characterize the cells as they age and in different environments. So I put the cells under mechanical and environmental strain, and I study their properties and mechanical behavior. So I hope to propose quantitative figures and value to product quality and to suggest improvement to our current storage protocol. So my current data shows that at any point, shapes import more than age when it comes to red blood cell mechanical properties. So I would suggest our next focus on research being on preserving the reversibility of the shape from echinocytes to discocytes. So through my data, I hope that we can have even better products that we currently have now at the blood service for a never longer time. So this would be especially relevant for rare blood types or in rural areas in Australia that are further away from collection centers and have a higher risk of shortage. So I'd like to conclude this presentation by reminding everyone that we can all make blood supply safer in Australia. So please donate today and save a life. Thank you.